I'll be talking about bones, the human bone to be exact. This is going to be mostly like the basics of bones because the next video I'll probably be getting into like the human skeleton structure, what functions of which bone is, and naming every single bone or whatever. We'll see. So I'm just going to start off with the basics. So the functions of bones is not just support and movement, but it also is protection, mineral storage, fat storage, and production of blood cells. The adult human has about 206 bones, by the way, but who doesn't know that? Shape and size does equal function of the bone, and bones contain both spongy and compact bone. Now, what is spongy and compact bone? Well, first up, spongy bone is a spongy looking type of bone found in flat bones at the ends of long bones. Long bones are like limbs, like legs and arms. Spongy bone is filled with a red or yellow bone marrow. Red and yellow bone marrow is two different things, by the way. Red is where the blood cells are produced, and yellow is energy storage. Bone marrow is inside spongy bone, creating the elements of our blood, like red blood cells, white blood cells, and platelets. And it's composed of stem cells as well. Bone marrow transplants are also used to treat lymphomas, leukemias, and other diseases. Um, by the way, bone marrow transplants are usually taken from the hips and replaces deceased bone marrow and can help with immune system generation. The stem cells are collected either from the blood or directly from the bone marrow. Now, the steps for bone marrow transplant is one, the patient receives pre-treatment to release HSC from bone marrow into the bloodstream, and then they collect the blood stem cells from the patient. Stem cells are then separated and removed from the remaining blood, and the remaining blood is returned. And then three, the stem cells are frozen until needed. Later on, they'll be thawed, and then stem cells are infused back into the patient, and the patient receives supportive treatment to help the bone marrow regrow. Now, that's just the spongy bone. Then we've got the compact bone. It's more dense, obviously, it's compact bone, and it can be found in the shafts of long bones and covered by perostim, a dense fibrous membrane covering most of our bones, essential for growth, repair, blood supply, and perception, or whatever that big word is. Anyways, there's two types of bone cells called osteoblasts and osteoclasts. Osteoblasts build and mineralize the bone. You can remember it as osteoblasts, build. And then there's osteoclasts, which break down and reabsorb the bone. They work together to maintain bone strength and homeostasis, which is very important. Um, Structural unit is the osteon, which consists of osteocytes within the cavities called leucinae, and then we move on to the tissue. So, bone is actually living tissue, by the way, while the solid matrix isn't. Matrix is the extracellular material that makes up most of the bone tissue, the scaffolding which living bone cells reside. So, matrix is like the scaffolding, and then the actual bone tissue is within that matrix. And bones have cartilage, which during developing the human skeleton is made of cartilage, is an advantage because cartilage can grow and adapt to the rapid growth of a fetus. Because cartilage can regrow and adapt way more quickly than solid bone can. Also, pushing through, like when giving birth, cartilage is a lot more bendy than actual bone. Then there's the types of cartilage. There's hyaline, most abundant and found at the end of long bones. Elastic, more flexible and found in the ear. Fibrocartilage. It's a cushion layer found in joints for shock absorption, which you really need if you like moving. Um, Beginning around 3 months, cartilage is slowly replaced but with bone, though even after 9 months, it's still mostly cartilage because they got like the birth process. But it grows. Speaking of bone growth, it occurs when the cartilaginous growth plates in the cartilaginous growth plates. Basically, there's cartilage like at the ends of the bones, and that's the cartilaginous growth plate. I'll probably have a picture or whatever. Um, it's stimulated by the growth hormone, which is released in the brain, like muscle hormones. Um, and it causes a release of growth factors, which cause the growth plate cells to divide and the bone to grow. Later on, sex hormones also stimulate bone growth. Stops towards like the end of puberty when there's like no cartilage to grow. So around 18 in females and 21 in males. Cartilage begins to slow down in dividing, and bone then replaces cartilage, and former growth plate fuses with the bone. Now, what about when your bone breaks? No one likes their bone breaking, but it helped. It happens. And there's different types of bone breaks and fractures. There's the non-displaced fracture, when the ends remain aligned, retains its shape. And then there's the displaced fracture. Ends don't remain aligned, changes shape of bone, and needs to be reset, which, ouch. Then there's closed fracture, remains under the skin, and open compound fracture. Fracture goes through the skin. So you can have a non-displaced fracture with a closed fracture, but you cannot have a non-displaced fracture with an open fracture. But you can have a displaced fracture with a closed and open fracture. It's really fun. Um, then there's the steps of bone repair. So bleeding at the bone will form a blood clot, and the fibroblasts will move into the area. Fibroblasts secrete collagen fibers, forming a callus. Fibroblasts also begin secreting cartilage, really like getting that area ready to be worked on. And then the osteoblasts invade, and the callus and transforms into the bone, and extra material is broken down over time by the osteoclasts. And eventually, like, it'll look a little bit bigger, but then it'll slowly be shaved down into its typical form. And then there's bone remodeling. It can occur without injury, by the way. A critical site for minerals, including calcium, so bone can be remodeled in response to calcium needs, which is controlled by hormones. There's calcitonin increases the deposition of calcium into bones, lowering blood calcium levels. Then there's pythyroid hormone, stimulates osteoclasts breaking down bone and increasing blood calcium levels. And there's the estrogen, impairs osteoclasts promoting calcium absorption. And then exercise can also influence bone remodeling too. New bone tissue forms along the lines of stress, so frequently used bones may actually change shape. Example is the knuckles of a pianist. Their knuckles are a bit bigger. Weight-bearing exercise can also increase bone strength, which is why like some people have like really thick leg bones and some don't. Anyways, that's all for like the basics of bones. Yeah, this is probably one of my longer ones. Anyways, bye.